as I get this video started. Now that I've found it, I can keep going. I hope you are all well. Today's topic is describing the data, the shape of the data. So a big part of 6th grade statistics is not only knowing how to create the graphs, but how to interpret and analyze them and describe what it is that we're seeing. If you were looking at the second standard within the statistics, standard 2, it talks about that you should be able to understand that a set of data collected, or understand a set of data collected is basically answering a statistical question, and it has a distribution which can be described by its center, its spread, and its overall shape. A lot of these things we're looking at here on this handout that you can find attached is it is stuff that helps us in the description of that data. So basically, I have almost everything you need here. I'm just going to use a series of highlighters to go through and indicate important things, and I will only add in just a few items. So the first thing is a cluster, and those of you who have been in class with me know that I have already used a few of these descriptor words in talking about some of the graphs we've been working with. So a cluster is data that is grouped closely together. So if I'm looking at this dot plot here about hours exercising per week, I have a cluster of data right here in the center between 3 and 6. So that tells me that most of the people surveyed exercise between 3 and 6 hours per week. In all honesty, it's really between 4 and 6 hours, but the 3 is so close there, we would group him as well. And the only thing I might indicate here on this graph is that no one polled, worked out, or exercised between 1 and 2 hours, and no one polled or surveyed exercise between 7 and 8 hours. And those would indicate a gap in the data, which leads us to the second descriptor word, a gap. And I apologize, my printer is not doing a very good job. This is very faint. I hope you guys can see it well. A gap in the data is numbers that have no data value. There is nothing there. For instance, right here, this says minutes to eat breakfast. No one spends 6 to 7 minutes eating breakfast that was polled in this dot plot. So, same thing here. Those are the gaps that we're looking at. Our next descriptor word would be a peak. A peak in the data is basically the most frequently occurring value or values, or it could possibly indicate the mode. So a peak, most frequently occurring, or the mode. For instance, here, the most frequently occurring is really right here between 31 and 40, and I did accidentally chop off the title of this graph, or what it is, so I apologize for that. But then we have another bar that does have a slight peak at 11 to 20. So no matter what the graph is talking about, I can tell where the peak is. So both of those would really be a peak in the data. Then something most of us should be familiar with anyway is symmetry. That's something that is common in math that we talk about a lot, and not just in math, we use that in other subjects. And symmetry is where the left and the right side here are mirror images of one another. And we actually talked about some symmetry in our reflections on the coordinate plane. So the left side and right side are mirror images. So here, if I split this down the middle, I can tell that the left side of the data is identical to the right side of the data. It goes up kind of in a U shape. They are completely symmetrical. Then the skewed left and skewed right. These are our misconceptions in data descriptions. So these are really, really tough for a lot of people to get correct, actually. A lot of issues with skewed left. Most of the time people think it's skewed left if all the data is on the left, but it's actually the opposite of that. So when we're talking in terms of something being skewed left, it means that the tail, I'm going to show you what I'm talking about by the tail. The tail is to the left with most of the data being on the right. So most of my data is on the right. So if I start and I draw myself a little tail, that tail is kind of going in the direction to the left to indicate it's skewed left. Very confusing for most to understand. It helps to draw that little tail or try to picture it, visualize it, which direction is that little tail going. And it tells you which way that the data is skewed. And I'm actually going to come back through in just a second, and I'm going to put little stars by these because they are our star descriptors. They're the tough ones. Still speaking of the left, I have not only a histogram, but I have this box plot. Look how here is the tail. See how long the tail is on the left-hand side? That is called a left tail, so it would be skewed left. Very, very tough to see most of the time. Very tough. Not for everybody, but most people. Sorry, you hear my pens, I'm switching them. The tail is to the right if it is skewed right, so it's the opposite of this one, with most of your data being on the left-hand side. So if I start here, and this one's not an extreme skew, but it is still a skewed. Here you can see how the tail keeps going to show it is going toward the right, it is skewed right. Same thing with this box plot here. There's my tail there on the right, therefore it is skewed right. I'm going to say a right tail just to do the opposite of what I had just finished. So again, what you're looking at is descriptor words that we use when describing the shape